So I have just one word for you, or maybe it's 2 words, I don't know, doesn't matter. Anyway, that word is microservices. Well, hello, wherever you are, whenever you are. Where am I? Melbourne, Australia, as usual. And when is it? It's August 2021. Now I hope wherever I find you, and whenever I find you, that I find you happy, safe and well. So yes, this is the big one. This is microservices. This is the course that I have been wanting to make for such a long time. And now it's finally here, free on YouTube. It was a lot of hard work, it was a lot of fun, but I'm glad it's done. Now, you will see from the timestamp that it's a long video, so I wouldn't expect anybody to go through it in one sitting. So with that being said, I have put the time codes in the description below. So that means you can jump to the sections that you want to go straight to, or you can come back and pick up where you left off. That being said, I do suggest you go through it start to finish for the best experience. Now, I have tried to put in the right balance of content for an introduction to microservices, but if you do have any feedback on how I can improve, please put that in the description section below. I always love getting your feedback. One last thing, just a big thank you. Thank you for joining me here on YouTube. And if you do like the video, please think about giving it a like. That just helps me out. And if you've not done so already, maybe think about subscribing, ding the little bell, and that way you'll get notified when I make new content. And finally, to my Patreon supporters who go that little bit extra and support me on Patreon, thank you so much to you. I cannot tell you how much I really do appreciate it. And as usual, as a way of thank you, your names are coming up at the end of the video. That's enough for me. We have got plenty to get through, so I don't think we should delay any further. And I think we get started. All right, so yes, welcome to this step-by-step course on .NET microservices, and we will also be using Kubernetes, RabbitMQ, and gRPC. So up front, I just want to, this isn't the course outline, we go through that in a second, but what I want to be very upfront about is just the approach we take in this course and the type of approach I've taken, which may or may not suit some people. So I want to be very clear about that up front before you invest too much time going forward. So this course will focus on the technical aspects of building .NET microservices, which shouldn't be too much of a surprise. So hopefully that's why most people are here. We'll cover the theory as we go, but I wanted it to be as practical and as technical as possible. And so we do theory, but I didn't want to do so much theory up front that it becomes maybe a bit tedious. So we cover it as we go, but there is a bit of a theory block up front as well. Take a pragmatic, balanced approach, but always try to follow best practices. But again, you do have to balance that. When you are developing in the real world, it's not a highly theoretical place, and you sometimes have to make tough decisions, pragmatic decisions on how best to go forward. So again, I've taken that approach in this course as well. It's fully step-by-step, so the code is available on GitHub, but I don't point you to a repository and just tell you to download code and point at it as part of the video. We actually go through every single bit of code step-by-step, line by line, and that goes for doing Kubernetes stuff as well. So that might not suit some people, I'm just calling it out, but that's the way I've approached it here. It is fully step-by-step, and that's why it's pretty long. Already covered this, be as practical, as interesting as possible, but also acknowledge that microservices are hard and they don't solve every problem in the world. So we do have to go into the course acknowledging that that is the case, and I certainly try and acknowledge that. Some things this course doesn't do, so I don't focus on things like domain-driven design, bounded context, a lot more of the kind of highly theoretical stuff about how you would design your business-focused microservices. I don't really focus on that. We touch on it slightly, and I make the point about, services should be bounded for sure, but I don't go into lots and lots of slideware or theory about that. We don't build out too much redundant business logic in our example. Our example is incredibly simple. Well, it appears incredibly simple. There are only 2 services, and you might think that's not enough to learn anything. Believe me, it is more than enough to learn the basics and the introduction introduction material to microservices, more than enough. And I felt if I introduced more services and tried to build out something like an e-com app, it would detract focus on really what I was wanting to try and get across. So we don't focus on redundant business logic about building carts and category pages and all that kind of stuff. Don't demonize the monolith or bandwagon jump. There are reasons and scenarios when you would definitely use a monolith and reasons where you would definitely not use microservices, which is probably the same thing. And I call that out and I give some examples of why we do that. So what I'm saying here, what I'm not trying to say here is that microservices don't cure everything. They're not the best approach in all circumstances, definitely not. And we don't cover everything. There is a balance to be struck, of course. You're never going to cover everything, and I certainly haven't covered everything here, but what I do feel I've done is given enough material that's going to give you a really good introductory foundation to building microservices with .NET technologies and all the associated stuff around that. I feel this course is going to give you that really good introduction foundation that you'll need to move forward. Okay, let's go through the course overview. So just FYI, there are 9 sections, 9 parts to the course, so we're just going to go through those now. So the first part is our introduction and theory, so we go through course overview, which we're doing now. Some prerequisites, which aren't mandatory, but kind of nice to have. The ingredients and the tooling that you'll need if you want to follow along. We then move on to some theory, so what are microservices, why you would choose to use them. We look at monoliths and why you would and would not use them as well. We then look at our services that we're going to build out. We do an overview of our solution architecture, and then we look at our service architecture, so how we're actually going to build our services out. We then start the practical build, and the rest of the course is fully practical from this point on, so it's all coding, config. So we start the platform service, which is our first service. So a bit of an overview of what it is. We scaffold it out, build out the data layer, and then we work on our controllers and actions. Part 3, we look at Docker and Kubernetes, so a review of Docker. We containerize our platform service, so we build it as an image and push it up to Docker Hub. We then go into Kubernetes, what it is, why you would use it. We look at the architectural overview of our application in Kubernetes, so that's the Kubernetes architecture section, and then we deploy our platform service into our Kubernetes cluster. And then finally in that section we set up some external networking so we can actually use our platform service inside of Kubernetes. Part 4, we start with our commands service, but really this section is focused on synchronous messaging actually. So we scaffold up our command service to start with, we set up a controller and action, and then we look at messaging, synchronous and asynchronous messaging. And as part of the synchronous messaging, we set up HTTP communications between both our services, our platforms and command services. So as part of that, we add a HTTP client to our platforms service. We obviously have to deploy our command service into Kubernetes. We do some internal networking, and we also stand up an API gateway. So it's a really big section where we cover an awful lot of material. Part 5, we move on to SQL Server. Every service has its own database, so this is the SQL Server for our platform service. As part of setting up SQL Server, we talk about something called persistent volume claims. We look at Kubernetes secrets. We deploy SQL Server to Kubernetes, obviously, and we revisit our platform service. And just a quick call out, if some of this stuff you don't know what it is, that's fine, we cover it all in the course. So if you don't know what a persistent volume claim is, do not worry about that, we obviously cover it in the course. Part 6, we revisit our command service and we talk about multi-resource REST-based APIs. So we review all our endpoints for our command service, we build out our data layer, and then we finish off our controllers and actions. That looks like a short section, but it's actually quite a long section. Part 7, we then look at our message bus, which is RabbitMQ in this case. So we do a review of our solution architecture. We give an overview of what RabbitMQ is. We deploy RabbitMQ to Kubernetes and we test it. Part 8, we then start to really build out our asynchronous messaging using RabbitMQ. So that involves adding a message bus publisher to our platform service. We look at event processing, and then we add an event listener to the commands service. And then to round out the course, we look at gRPC, so an overview of what gRPC is, why you would use it, all that kind of stuff. We'll do some final networking configuration inside Kubernetes. We'll then add a gRPC server to our platform service, we create a proto file or a protobuf file, and then we add gRPC client to the commands service. And to round it off, we deploy all that and we test it all end to end. All right, so let's move on to the course prerequisites. Now again, these are just suggestions. We do everything, as it says, they are fully step-by-step, but some of the stuff is quite complex. And if you've not touched it ever before, you might find some of the concepts a little bit heavy going. So I do have courses for all this stuff, pretty much, on the channel. So if you're a bit rusty, maybe you want to brush up on the following. So experience with building .NET Core REST APIs. So I have a full course on my channel that covers that in detail. Although we do it again here step by step as well, but I do spend more time on bits and pieces in that video. Understanding of Docker and associated concepts. Again, if you've never touched Docker before and you don't even know what it is, we do cover it here, but again, doing a more detailed course might help you out. Dependency injection in C# would be useful. Again, we do cover it here, but some of my other courses go into it in a lot more detail, the more sort of basic theoretical concepts. And if you've used async and await before in the C# language, that would definitely be useful. But again, that's probably not super critical. So all of this stuff would be useful. We do cover it all step by step. But again, if you've not ever built an API before using .NET, C#, you might find some of the stuff a bit challenging. All right. So these are the ingredients that you're going to need if you want to follow along practically, which I think most of you probably will want to do. So I'm using VS Code text editor. You can use Visual Studio if you want, but again, I'm deciding to use VS Code. I just find it lighter and more adaptable than Visual Studio, but you can use Visual Studio if you want. .NET 5 is sort of mandatory. There's some concepts in here. If you decide to use an earlier version of the framework, you may run into some little niggly problems, so I highly recommend you run with .NET 5. You'll need Docker Desktop running Kubernetes, again, which is free. An account on Docker Hub, again, which is free. So when we push images up to Docker Hub, you obviously need to have an account to do that. And you'll need either Insomnia or Postman, which are basically API test clients, which we will be using throughout the course to test our services. And in this video, I'm running everything on my local hardware. I did have a decision to make on whether to go with this approach, running everything locally, or whether to go with a cloud provider like Google Cloud or Azure. I decided that this course would be using just your local machine, so you don't have to sign up for cloud services, which I know doesn't suit everybody. But the downside of that is, yes, we will be running up quite a number of services, so you do need a decent level of local hardware. So I'll just show you my PC spec, just out of interest. Now this is probably a higher spec than you need, but I'll just go through what I've got anyway. So yeah, we'll be spinning up a lot of containers in Kubernetes, which obviously has an impact on your local hardware, most especially memory, really. So I've got an Intel i7, I've got 32 gig of memory, which is probably way more than you need. In fact, it is definitely way more than you need. It's just what I happen to be running. 16 gig will be absolutely fine. So 16 gig, you should be totally fine. Anything less than 8, I mean really 8 is probably the minimum, the absolute bare minimum, and I think even if you're running 8 gig, you're probably going to struggle a bit with that. So between 8 and 16, I'd recommend 16 to be honest with you. And the hard drive is sort of irrelevant, but I just happen to have a 1 terabyte solid state disk drive. But it's really the memory. Memory is the main thing that you will need. So yes, 16 gig, you should be fine. Now, the other thing I want to call out is we are doing a lot of Kubernetes stuff in this course, so I have produced a free cheat sheet that you can download. It's a nice one-pager that you can refer to, so either on screen or you can print it off, and it has all the Docker and Kubernetes commands that we're going to be using in this course. So it's a nice little one-pager reference guide. It has our Kubernetes application architecture reference on there, so again, you can kind of tick off what we complete as we move through the course, and we also have a Kubernetes object glossary. So again, if you're new to Kubernetes, we cover it all in the course, but again, everything that you see on screen here is on a nice little one-page summary for you to download. So all you have to do is go to .netplaybook.com, that's my blog website, and just register for our mailing list, and we will subscribe to our mailing list, and we'll email you with a download link. And I do want to call out that we never, ever, ever pass on your email address to anybody else. In fact, I hardly even use the mailing list at all. I probably send out an email maybe once a year or something, and I definitely do not pass it on. So just be assured, if you do give us that, it's totally secure and we don't ever pass it on to marketeers or anything like that. Other course resources, the code is available on GitHub for you to download and follow along. There is a lot of code here, there's a lot of scope to make errors, and I've made a few errors as I've made the video, which you will see if you follow along. Don't worry, I do correct them, but it's always nice to have that backup of a code repository so you can refer back to and compare what you've done. In the description of the video, I have put timestamps to all the sections, all the main sections in the course, so it's a very long video, so I don't expect anybody to go through it in one sitting. So the course outline description, in the description, you can jump to each section and come back and revisit at your leisure. And then finally, the course slides, the stuff that we're going through. There's quite a few slides that we're going to go through. I'm not making those available publicly, but they are available to my Patreon supporters. The $5 supporters and above can download the course slideware through my private GitHub repository. So if you're interested in that, maybe check out my Patreon site at the following address. All right, so let's come on to talking about microservices now. We've done enough introductory stuff. So what are they? And rather facetiously, I'm saying, how are they saving the world? Not being totally serious when I say that. So let's look at this idea of a single responsibility principle, which was coined by this chap, Robert C. Martin. And what he's saying is, gather together those things that change for the same reason and separate out those things that change for different reasons. So what does he mean by that? Or what do we mean by that? Well, that really is a nice way to kind of, at a high level, think about microservices. So what are they? They are small, okay? They are built, let's say, by a team that would consume 2 pizzas. That's a way that we often measure team size. So imagine, at the end of the sprint, end of the week, you want to treat your team to pizza. You only need to buy 2 pizzas to satisfy this team. So small team. Or if you want to think about it and how long it would take to build a typical microservice, you're looking at maybe 2 weeks to build. That's what we mean by small, although that is quite a subjective term. They are responsible for doing one thing well. So you kind of have this idea of a microservices application, which will include many, many different services. Each of those services will do one thing and do it really well. Okay, so again, go back to that single responsibility principle. If something's doing one thing, does it really well, it doesn't need to rely too much on the other parts of the system. Although paradoxically, in order for it to be a microservices application, services typically will talk to each other because they need to share data between themselves. But you don't want it doing so much sharing that they're chatting to each other all the time. So that's why breaking down your services into doing one thing and doing it well is really important. They're organizationally aligned. So think of a large organization. The parts of that organization will typically be responsible for running and managing a set of different services, and they have almost exclusive control over those services. So they can change them when they want to, and they can make additions to them, take them down when they need to. And other parts of the organization, they will have their own set of microservices that are aligned to their part of the business. And again, they will need to, or most usually, they do talk to each other. This is really important. So again, we will talk a lot about decoupling and the fact that you don't want services talking huge amounts to each other, but at the same time, again, paradoxically, in order for it to be a full microservices solution, the services typically form part of a distributed whole. So one service doing one thing by itself, never talking to anything else, is that a microservice? Possibly it's not, okay? It really is a true microservice when it does form part of this larger distributed system. And again, this is we've already kind of covered this, self-contained, autonomous. So again, they are responsible for doing one thing. They can stand on their own without being too reliant on other things. All right, so just to help position what microservices are, let's look at the contrasting side of things and look at monoliths for a bit. Now, you might be wondering what a monolith is. So probably the best way to describe it is by reference to an actual system. Now, the system I'm going to describe here is actually an amalgamation of a number of systems that I've worked with or been across at various points in my career. But one thing is definitely, for sure, if you work in a large organization, there's a very, very strong chance that you have a system like this in that organization, in your organization. So this is a sort of example of something that I have come across on my travels. So a large monolithic CRM system that services millions of customers. So it's a really, really super important system. Evolved over many years. So again, it's not something that's been stood up within the last 6 months. It's been around for many, many years in an organization that itself is many, many years old. Built on a single proprietary technology stack. So obviously there'll be different technologies that make up the monolith, but for the most part, it will be built on one platform, one tech stack. And in this case, and in most cases, it will typically be managed by an outsourced partner. So it won't even be managed by the organization itself directly. Most usually, or a lot of the time, systems like this are managed by third parties. So what's wrong with that? Well, this system is very, very difficult to change. It's a huge code base. Making changes even to a small part of it, you have to make sure that it hasn't impacted any other part of the code base. So change cycles are months in duration, and even for big migration projects, if you're maybe migrating from one monolith to another, they can be years and years in duration. But for this particular one I'm thinking about, the change cycle was at least 3 months. Lots of testing, often frequently manual testing to make sure that nothing has broken when you make changes to these systems. So difficult to change and therefore very slow to change. Difficult to scale. Now, what I mean by that is, the CRM platform is a huge system. And let's say, for example, you are going to experience increased orders at certain points of the year, say, near holiday periods or something like that, or, Black Friday sales or something like that. You may want to try and scale the part of the system that just deals with ordering, and all the other parts of that system don't need to necessarily scale as much. But with a monolith, you can't do that. You have to scale the entire system. So quite difficult to scale specific bits of the system. You can scale it, but it means you have to scale absolutely the whole system, which makes it quite inefficient to scale. And then finally, you're locked in. You've got one big, huge platform. It's locked into the technology stack, pretty much. Very, very difficult to change the technology stack. And also, if you're using an outsourcing partner, you're locked in from an intellectual property perspective as well. So this one party knows everything about that platform, which is fine, but you can't then choose another party to manage that system. Well, you can do, but it'd be very, very difficult to do so. So you're kind of locked into that vendor managing this platform. It's not a great situation. So this brings us on to the benefits of microservices when you kind of contrast that with that example monolith. Definitely easier to change and deploy, basically because they're smaller and they are more decoupled. Can be built using different technologies, so you're not locked into the one technology stack. Typically, different teams will build different microservices, and it's really up to them to choose what technology they want to use to build those microservices. So long as they can talk to each other, the services, it doesn't really matter what they're built with. You have increased organizational ownership and alignment. So the CRM system, there'll be many different parts of the business that are relying on that system. And if one part of the business wants to change it, another part of the organization may not want to change it, or they may have their changes that they want to prioritize over the other part of the business. So it becomes this headache of managing priority, managing change, whereas with microservices, typically each part of the business owns their own services, and so they can change them and prioritize their own changes till the heart's content, really. Resilience. So we'll see this with an example in a minute. One service can break, that's fine. The other services will continue to run. Whereas with a monolith, if the monolith goes down, typically the whole thing will go down. So you'll end up with this situation with microservices where parts of the system may be down, but other parts will continue to run. And I've got an example coming up. And scalable. So coming back to this issue of scalability, with a monolith, you can scale it, but you have to scale the entire thing. So it's rather inefficient to do so. With microservices, you can focus and scale out just the services that you need to scale. You don't need to scale everything. So it's much more adaptive to different demand patterns. And they're built to be highly replaceable and swappable. So that's the whole point of them. If you are not happy with a particular service, you can replace it with another service built by the same team or possibly built by a different team. But the whole point is that they can be swapped out. You're not locked in. All right, so let's come on to an example of a relatively simple microservices application that kind of talks to some of the concepts that we've just mentioned. So let's say we have an airline and an airline has decided to go with a microservices architecture. You could split your application up as follows. So you would have could have a flight catalog service. So that's the service that contains all the flights that people can book. And let's say, for example, in this example, it's written in .NET with a SQL Server database. And we have, in this case, one running instance of that service. And it's built by a team, let's say, based in Scotland. We then have a second service. This is the booking service. So let's say, for example, it's built using Ruby on Rails. It has a different type of database, PostgreSQL database. We have one running instance and it's built by a team in the USA. And what you'll see here, which is quite obvious, is that each service has its own data store. So the flight catalog will use its own data store and the booking app will have its own data store. Now, these services will more than likely share information, and that's really what the whole of this course is based around, is how do these services share information that the other one relies upon. But one takeaway is that they do not share the same database. They may share data, they will not share the same database. And it comes back to this whole point that one of these instances can go down, the other one will continue to run pretty much uninterrupted, possibly with some limitations. And then to round out our airline example, we'll have a check-in service. So somebody uses the flight catalog service to browse flights. They will then use the booking service to book a flight. And then finally, at the airport, they will check in, or they can check in online. So they all have different domains. They may be run by different parts of the business. Our check-in service in this case is written in Node. We have one instance and it's using a MongoDB. So again, to labour the point, it has its own data store and it's written by a team in India. So the takeaway from this slide is that separate services written by different teams, they have their own database and they will be somewhat reliant on each other. So for example, you won't be able to check in unless you have access to booking details. And again, the whole point of this course is to understand how we can move data between services, but they are independent. So for example, if the booking service went down, people can still browse and look at the flight catalog. So they can still go online, they can still see what flights are available, they just can't book. And likewise with check-in, people can still go to the airport or they can still check into their flight online. They might not be able to book a new flight, but they can still check in. Or let's say the check-in service goes down, people can still browse flights and they can book flights. They just can't check in. So the point of this is that even though one of the services may go down, the others remain up and certain parts of those operations that they are responsible for will continue to run. Unlike a monolith where the whole thing goes down, everything goes down. And of course, what we're going to explore in this course is the fact that even if a service does go down, we'll be able to recover them much, much quicker. The other thing is to talk about scaling. So let's say this example airline has a sale on and we have lots of people coming to the website to look at flights and book flights. You can scale out additional instances of those services. And the check-in service, you leave untouched because the number of check-ins probably isn't going to change unless you maybe increase the number of flights. But let's say in this example, the number of flights remain the same, but we have a run on cheap flights that this airline is running. And you can scale up and scale down your instances very, very easily. So that brings us on finally to say, so does that mean everything about microservices is awesome and everything about monoliths is completely terrible? Absolutely not. And on this slide, we have some disadvantages of microservices, or certainly some things to consider when you use microservices versus using a monolith. So microservices are difficult to implement. There's no getting around it, they are difficult to implement. Writing an individual service might be somewhat okay, but designing and building an entire microservices architecture is difficult. When you're starting out, especially with a greenfield site, microservices may not be the best approach because if you don't understand the problem domain, you may spend most of your time just analysing the best way to break down and compose your services, and you may end up just in this analysis paralysis where you end up not building anything and you just keep going round in circles trying to determine what microservices you should be building. So yes, you need strong domain knowledge, and so in a greenfield site that may be difficult. Microservices are distributed. So that's something that people tend to forget about, and when you're running, in a development environment, you're not really taking into account the fact that these things necessarily are running over a network. So you can have services running in different geographies that rely on the network. And of course, the network can fail or it can slow down. And so that's something you really need to take into consideration when building microservices. And paradoxically, we keep going on about this concept of, microservices are totally decoupled. Well, as a paradox, they still need to be coupled to something. A microservice that doesn't talk to anything else is probably not actually a microservice. It's maybe a mini monolith or something like that. So yes, you want to reduce lots of chatty messaging between services, but ultimately, in order for them to function as a microservice architecture, they need to be coupled to something, even if it's just a message bus or the database, or more than likely other services. So the good things about monoliths: simpler to implement, no doubt simpler to implement, at least initially. You still can use CI/CD, daily deploys, you can do small changes. So the example I gave of a monolith, it was a huge beast of a system, and you were unable, just given the history of that application, to have a CI/CD type pipeline, do daily deploys, all that kind of stuff. But you can absolutely do that with a monolithic system, assuming that you build it in the right way to begin with. So one of the advantages of microservices is, you can use an agile approach to deliver them, and that's absolutely true, but it's also true of monoliths. So just because it's a monolith doesn't mean to say that you cannot deploy changes daily for a monolith. You absolutely can, but you have to make some considerations and build that application in a particular way, but it is still absolutely possible. Building a monolith is also a great exercise in familiarizing yourself with the domain. So again, especially if you're like a startup or something like that, and you don't really know your domain that well, and you don't even know if your organization is going to be around next year, spending thousands and thousands of dollars building a microservices application where you don't really know the domain may be absolutely a terrible idea, and you may end up spending half your time, just trying to analyze the problem. Whereas if you just go about and start building a monolith, number one, it's a bit simpler to implement, at least initially, and it also is a great exercise in familiarizing yourself with the problem domain. And so if you're one of the lucky startups that actually does start making money, then that's fine. You can then possibly move to a microservices architecture at that point. But at least if you've taken this approach and gone with a monolith to begin with, you're probably going to get up and running much, much quicker. And also you're going to start to understand your domain. So when you do come to actually implementing microservices, you'll probably compose them in a much more efficient way. And you can still have 2 or 3 big services. So this is kind of like a hybrid type approach, I suppose. You might not have microservices where you've got tens or even hundreds of services. You may end up just having 2 or 3 big, maybe not services, but 2 or 3 big applications that each don't do just one thing, but kind of take care of a bunch of stuff that's kind of similar. So it's a kind of halfway house sort of approach, and that may work well for some people. And generally speaking, monoliths won't be as reliant on the network as a microservices application. They're typically not considered distributed applications, so you do not have the same considerations around network latency or even network being unreliable as you would with a microservices application. All right, so let's come on and take a look at the services that we're going to build in this course. And we have 2 services that we're going to build. Now, our first one is the platform service, and that's what we will refer to as throughout the rest of the course. And it's basically going to function as an asset register for our fictional company. So it'll be used to track all the platforms and systems in our company. Now, we're not building out a full asset register system, just to be upfront with you, but we are going to build our platform service to operate in that way. But that is the idea behind it. And most importantly, it's built by the infrastructure team. So this particular team, they have a strong interest in maintaining a running asset register of all the systems in the organization. All right, so let's come on and take a look at the 2 services that we're going to spend our time building as part of this course, and we have two services that we're going to build. So let's move on to the first one, and this is our platform service. Now, what is the platform service? Well, the idea is that it's basically going to function as a sort of asset register. So it's going to contain all the systems, all the platforms that our fictional company is running. So yes, as it says, they're used to track all the platforms and systems in our company. And it's built, in this case, by one team, the infrastructure team. So may not be called infrastructure team in your organization, but maybe you might call it the operational team or the ops team or even the DevOps team. So that's the team that build it. That's the team that's owning it, and they will more than likely prioritize their changes against it. But it's not just to say that they're the only team that will use it. Yes, of course, they will use it, but it may be used by the technical support team systems. So again, faults are raised. You may want to know what system you are raising a fault against, and the technical support team will more than likely consume data from this service. Engineering team may want access to it for similar reasons. The accounting team, they may need access to it just to understand the assets that we have in the organization and what we need to write down each financial year, all that kind of horrible stuff. And even procurement. The procurement team may be interested in data that this platform service provides when it comes to renewing licensing agreements or signing new contracts, all that kind of stuff. So yes, owned by the one team, built by the one team, but will be used potentially by many other teams. So our second service is the commands service. And what is this? The command service basically is acting as a repository of command line arguments for given platforms. So the idea is it's going to aid in the automation of support processes. So imagine the concept where you may need to restart systems in a particular way, or you may need to understand how to back up databases in a particular way, rather than memorizing reams and reams of different command line snippets for different types of platform. This service is going to contain a repository of all those command line snippets. And so built by the technical support team. So this is the team that's going to build this repository. They're going to run it and support it, and they are going to be the principal users of it. So used by, the technical support team. May also be used by the infrastructure team, may be used by the engineering or development team. They may have an interest in getting access to this as well. Now, one thing that's going to kind of recur through the course is the fact that I have the word platforms on this slide, and that's no accident. The command line service is somewhat reliant on the platform service, and getting that platform's data into the command service is one of the things we're going to focus on as part of this course. But takeaway, two separate services can theoretically or should be able to run completely in isolation of each other, even though there is somewhat of a dependency between the two of them. All right, so let's come on and take a look at our overall solution architecture. So this is kind of the 50,000 foot view of what we're going to build. Now, this does not reference Kubernetes or any Kubernetes type objects just yet. When we come on to doing Kubernetes, I kind of overlay all the kind of Kubernetes concepts on top of this view here. So this one is abstracted away from that, and it's really just the components that we're going to build or use. So with that being said, first service we're going to have is our platform service. It will have its own SQL Server database, and together that kind of forms the entire microservice. It's basically going to be a REST-based API. So the public interface, the interface that our consumers are going to use, is a REST-based API. And yes, this service sits within what we're calling our internal microservices domain. Now we can theoretically access that API directly from externally into our internal microservices domain, and we will do that just while we're developing. But ultimately, we're going to use this concept of an API gateway, which is really going to front up all our services. And so any external requests coming in are going to then get routed internally to our relevant services. And so in this case, you can see our API gateway is routing through to our platform service using its REST API. Then our command service, it's going to have its own unique database just for it. Just for quickness, we're not going to stand up another SQL Server. We're just going to continue to use the in-memory database. But the important point to note is that it's absolutely got its own database. It does not share a database with the platform service or any other services for that matter. And it too is a REST-based API, and it too will make use of the API gateway will route through to our command service. So taking a look at this now, it's all great and everything, but is this really a microservices architecture? To be honest with you, I would argue and say that at this point, looking at the screen at the moment, I would say this isn't really a microservices architecture. Mainly because the platform service and the command service are completely and utterly, totally unaware of each other, which you might say is a good thing, but there's no data sharing between the two in any way at all. They're really just totally separate apps that happen to go through an API gateway. So again, there is a paradox here. You do want to have services decoupled, you do want to have them independent, but at the same time, you don't want them so independent that they don't talk to anything else. That is the paradox. So in order for it to be a microservices application, in my view anyway, there needs to be some degree of data sharing between the two. And that brings us on very nicely to looking a bit more at our command service. So what you can see here is a snippet of what the database may look like. And you can see that we have a list of command line snippets, how to do a particular thing, such as stop a service or restart services or generate migrations. And you'll see that we have those command line snippets. But most importantly, you'll see that our command service does rely on the fact that it needs platform information. So for the majority of this course, what we're really going to be concerned about is trying to understand the best way of getting platform data from our platform service down into our command service. Now, as we've said before, the command service cannot reach into the platform service database. Absolutely cannot do that. One approach possible would be that we kind of couple quite tightly the platform service to the command service. And what I mean by that is, once we create a platform in the platform service, we could theoretically get the platform service to post using HTTP to the API of the command service and say, here's a new platform that I have created. This does create quite a tight coupling between these services though, because the platform service absolutely has to know where the command service sits. And that does kind of create this concept of a coupling. So really what we're going to focus most of our attention on in this course is the idea of using asynchronous messaging via an event bus or a message bus. And so what we're going to do, similar sort of scenario, when we create a new platform in the platform service, we're going to publish an event onto our message bus. Now, all the platform service is aware of at this point is the fact that there is a message bus. It is not aware of the command service, nor does it care that there is one. And in this case, what we're then going to do is we're going to get the command service to subscribe to the message bus and receive those platform published events, and then it will add those platforms to its own database. So this idea of creating data in one service, in this case a platform, and it subsequently making its way down to other services is something that we call eventual consistency. Again, services don't share the same database, but they do need to share the same data. And so the main problem that we're really looking at here is how do we make sure that all these services have all the data that they need and data that may come from other services. So in this case, we're going to use a publisher-subscriber model, synchronous messaging to get that information down into our command service. And again, to labour the point, the platform service does not even know that the command service exists. And again, we're only going to do 2 services as part of this video, but as you can see here, you may have other services that publish other events onto the event bus and subscribe to other events or similar events. And you can see again that the XYZ service has its own database, the ABC service has its own database, so on and so forth. So you have this decoupled architecture, event-driven architecture, which is really what microservices are about. So to round out our solution architecture, we are going to make use of gRPC, and gRPC is used quite a lot in microservices, so for that reason I've included it. And what we're going to use gRPC to do is allow our command service to reach out to our platform service and pull down any platforms that it doesn't already have. But the point to note about gRPC is that it is synchronous, it's not event-driven, and so we are coupling our command service to some extent to our platform service. Okay, so let's move on to taking a look at our service architecture. So again, we'll look at the main components that make up both our services. So we'll start with our models, our internal data representations. We'll have a DB context, which mediates those models down to our persistent layer, in this case SQL Server. We're going to make quite extensive use of data transfer objects, DTOs, which are external representations of our model data, and they're mapped, as you can see there, to our models. And we're also going to make use of a repository pattern, which just abstracts away our DB context implementation. We're going to have our API REST controller, which is I'm calling synchronous in. So HTTP requests coming in, we'll say externally, reach into a repository, pull back any data, and then send back the HTTP response using a DTO. So that's really our external contract going out to our external consumers. We're also going to have a HTTP client, which is, I'm calling here synchronous out, and it's going to make HTTP requests to our, in this case, command service and receive back a response. Now, I'm including this just for completeness, just as an example. We're not making extensive use of this, but we are going to build it out just to demonstrate that particular approach. We're then coming on to the main event, which is to use a message publisher, which is asynchronous out. And so our platform service, yes, is going to publish events onto our event bus, onto our message bus. And then finally, we're going to use gRPC within our platform service as a synchronous in service. And so clients, in this case our commands service, can use gRPC to request platforms back from our platform service. And we're using gRPC to do that. Now, an important point to note, the only external interface here is our controller, our HTTP Web API controller. Everything else that is not denoted by a green line is internal within our microservices domain. And as you can see from the darker coloring on the publisher, it's asynchronous, the other ones are synchronous. So command service architecture, I'll just go through these quickly, it's exactly the same. Again, this is exactly the same. We're going to have a controller, synchronous in, responding to HTTP requests and giving HTTP responses. We're going to have a message subscriber. So this is asynchronous in, so it's going to receive messages from the message bus. And we're going to have a gRPC client, synchronous out. So this command service is going to make requests to our gRPC service in our platforms service. And again, the only external interface here really is our Web API controller, right, REST API controller. And with that, I think we start coding. All right, so I'm going to come over and we're going to start to build our platform service. So I'm just going to start a new Visual Studio Code window, and I think it's probably started it on my other screen. Indeed it has, so let me just pull that over. Rather annoying. Now I've got my screen running at 150% magnification, so hopefully that's large enough for everybody to read clearly what's happening on screen, but at the same time balance that it's not too cramped for writing code. So I might change it if it's not, if it's a bit too cramped, but I think this is going to be okay. So I'm going to bring up the integrated command terminal by doing Control and back quote, and then change into my working directory. Now this will be, chances are something different for you, but for me it's on my D drive and it's season 4 and then it's episode 3. Do a quick directory listing and it's empty. Now we're going to create a few projects in here as our main sort of solution folder, but for the moment let's just work with individual projects. So the first one we are going to set up, now actually before we do that, let's just do a .NET version, --version, just to check the version of .NET that we have installed, and it's version 5. I would strongly suggest you use version 5 and not 3.1, which probably will work, but you might have to make some tweaks here and there to get it working, so go with version 5. All right, so I just did a CLS to clear the screen, and we're going to do a .NET new. Web API is the template type that we want, and then we give it a name of platform service. And I'll just make sure I've spelt platform and service correctly. Looks like I have, so hit enter. And that will go away and scaffold that up for us. So quick directory listing will confirm that that is the case. So I'm just going to do a code, open this recursively, and I'm going to open this folder up. So platform service. And that will open our project up for us in Visual Studio Code. Now, I'm assuming that you are somewhat familiar with web APIs in .NET. As I say, if you're not, then I would suggest you check out one of my other videos that I've put links in the description below to. We'll just click yes to this, and this will just create a .vs code folder, just so it remembers our settings and so on and so forth. So I'm going to delete the weather forecast class. It's just like a class that's used by the templated project. And I'm also going to come into controllers, and I'm just going to delete the weather forecast controller. Fantastic. And then you should be familiar with the regular anatomy of a Web API project. And we've really only got a controllers folder now empty, but don't worry, we will be populating that relatively soon. But the first thing I want to do is really just start to add in our dependencies, our package dependencies that this service will require. So again, I opened up my start menu there. So control and back tick to get the integrated terminal up and running. And I like to leave the platform service CS proj file up and running. So as we add packages, you'll see them being added to this file, just to make sure that we've not made any typographical mistakes. So the first thing I want to add is .NET add package, and the first one is AutoMapper. And I'm actually just going to copy the package name from my notes over here because it's a little bit long-winded. There you go. So it's automapper.extensions.microsoft.dependency injection. I'll hit enter. I'm sure you don't want to see me typing that in. And you can see it's been added as a package reference to our CS proj file. And then the next one, .NET add package. And again, I will save you from my typing because I'm sure you don't want to see me type out some rather long package names. This one's a bit shorter though. Microsoft Entity Framework Core, which of course our database context class will be using to communicate to initially our in-memory database and then subsequently our SQL Server database. But we do need a few more packages in that space. So I just did upkey, so .NET add package, Microsoft Entity Framework Core design. You need that one as well, and that's just at design time. This does not get included at runtime. And then the last one in the, well actually no, it's not the last one, we got two more to go. So Microsoft Entity Framework Core. We are initially going to use an in-memory database because it's just a lot simpler than connecting it into SQL Server, but we will of course use SQL Server eventually. But yeah, we do need Microsoft Entity Framework Core .in-memory. And then the last one in this kind of Entity Framework Core is of course SQL Server. So Microsoft .entity framework core .SQL Server. And I think that's us good for now. So you can see that there was one other package in there, the Swashbuckle. That just gives us an open API spec out the box, which is quite nice. We might take a look at that later if I remember, but for now, we're going to leave it at that. Now we are going to add other packages, but I'm not going to put those in just yet. I'm going to wait till we come to the relevant section and then we'll add those in. I'll just have to make sure that I do remember to do that. So for now, that's good. Our application is scaffolded up. We've included our packages, so now we are going to move on to adding in our model. All right, so back over in our project, we're going to create our first model. Well, in fact, our only model for this service. So in the root of our project, I'm just going to right click and do new folder. And I'm going to call the folder models. Although we're only going to have one of them, doesn't matter, use that naming convention anyway. So right click on the models folder and new file, and the model is going to be called platform.cs. So it's just a plain old C# class. And this is really our internal representation, our application's internal representation of our data. Why am I saying that? Well, we go on to use data transfer objects in a bit, which are basically our external view of our data going out. So models internal, DTO's external. All right, so namespace, which should be platform service, and then we'll do models. All right, and then the name of our class is just a public class is platform. And this is probably going to attempt to autocorrect. No, it didn't. Great. That's it. So it's public class, and then we're going to add some properties to it. So to sort of shortcut writing properties, if you type prop and then tab, and then you can tab through the property that it's created. So yes, this instance, we do want an integer, so tab over, capital ID to give us our model ID, and that will eventually become our primary key down in our database. Next, prop, so again, prop, tab is this time a string, and it's just going to be called name. I'm only going to do a few properties here. Next property will be another string, and I'm going to call this publisher. Okay. And then the final property, and we're not really going to use this, but I just want to labour the point. I'm going to create another property, just make it a string for simplicity, but I'm going to call it cost. Now, while that's a bit of an ambiguous property name, the point here is that for this service, you might want lots of properties that describe the platform. So cost might be how much it costs, or it might be its annual subscription, or it might be a support cost, or it might be the cost to run. And you could add all these in, as well as lots and lots of other properties very specific to this domain, to this microservice. It's a platform service, it's an asset register. You might have loads of attributes in your platform model that you might want to have there. Spoiler alert, we're going to have like platform representations elsewhere in our microservices ecosystem, in our commands service specifically, and it's just not going to be interested in that type of data. So the point I'm making here is, yes, you're going to have this concept of a platform that permeates throughout our system, but different services will have different views on what that actually means for them in terms of the context of what they're trying to achieve. Okay, so a bit of a long-winded way to say that you could have loads of stuff in here that other services just may not be interested in when they come to modeling or representing this type of data. Cool, so let's just save that off. And then the only other thing we want to do, just to help Entity Framework along a little bit, is just decorate these with some annotations. Now, the first one I'm going to use is the key annotation, just to say that this ID is going to be a key in our database. So make sure your cursor is in the offending article. It's got the little red squiggle under it. Make sure your cursor's somewhere in there, and Control and period to get Visual Studio Code to give you some code suggestions. And I'm going to select the first one here using System Component Model Data Annotations, and we'll add that in the top for us. Now, we're going to be doing that control period about 1 million times, well, not 1 million times, but a lot throughout this course. I'm not going to say it again, although I'll probably mention it again, but that's how you get those code suggestions up. Now, just a word of interest. By default, Entity Framework Core would interpret this property as a key. You don't really technically need to specify that it is a key, but I just like to do it just to be a bit more complete. And it also acts as kind of in code documentation, although it's not really documentation. This is similar. This is not actually required because a primary key is of course mandatory, so you don't really need to have the required attribute, but I just like to put that in because, well, I'm maybe a bit weird. And then I'm going to make all these other properties required as well, so they cannot be null. All right. So that's it. It's a very simple class, and you might be going, that's a bit too simple. Believe you me, you don't want it to be any more complex because there's a whole lot of other complexity coming down the line, so we want to keep it relatively straightforward and relatively easy to understand. Cool, so that's our model created. We'll move on to the next section, which is looking at our DB context. All right, so the next thing we want to do is create our DB context. So again, just pay a quick visit to our architecture. So we've created our model, just a platform model. We're now creating our DB context, which effectively maps our models down to our persistent data store. Now, to begin with, we're just using an in-memory database, but we will move to SQL Server eventually. So this is the next thing that we're going to tackle. So back in our project, new folder in the root, and I'm just going to call this data. I'll put a few data related things in here and right click and new file, and we'll call this appdbcontext.cs. And then namespace is just platform service.data. And it's just a public class called appdbcontext. And we're going to inherit from the base DB context class. And it's probably going to try and autocorrect here, but let's see how we go. Yeah, it did. So just go back and take that back out and just say we're inheriting from DB context. So we want to bring in that namespace, so control period, using Microsoft Entity Framework Core. Fantastic. And then we just want to create a constructor that we can, if we need, pass in additional options if and when we need them. So constructor, actually short code for constructor is ctor tab, and then you can just tab through, and we're going to pass in one parameter, which is DB context options of type oh, well, whatever our class happens to be, so DB context. And we'll just call that OPT. And we can get that from base. Okay. And we don't need to put anything in there just yet, but that's our constructor, that we'll use for this. And then most important, well, it's as important, we need to define a database set, or a DB set, and which relates to our model. So that's really what's telling our DB context